and the circle. This is the circle that is given. We have these different kind of circles, like some rules for circles. So one of them is concentric circles. Are the circles that are on the same plane, they have the same center. So these are the both concentric circles. That means they have the same center, and they're like, just as the word says, concentric. So they're going like, it's like the same when you throw in the water like rock to sand, they're making like concentric circles. Sorry, someone has like really noise from the background. Turn it off, the mute the voice.
It is converting biomass.
Okay, so next we have congruent circles. These are circles that have the same radius. They don't need to have the same center, but they have the same length of the radius. These are said congruent circles. Let's see. I'm sorry. Okay. Next, we have a tangent. A tangent is a line that is on the same plane as the circle and touches the circle just in one point. So it's like this. This is a tangent. Just it's a line that touches the circle in one point. Can be in every single point of the circle. Just needs to touch it in 2 points. Done. Second is the same line, but touches the circle in 2 points, 2 different points. This is a secant. And the last one, chord, is a line segment whose endpoints both lie on a circle. So it's the same kind of like secant, just it's not a line. It's just a line segment. So it has first point and end point. Like it's not a line. It's a segment. So now we have like a theorem for circles. This is that if the line is tangent to a circle, then it's perpendicular to the radius of the point of tangency. That means that the radius of the circle is perpendicular. That means that is in this angle is right angle, or is an angle of 90 degrees. That is the angle of the tangent, and the radius that goes to the circle, to the center of the circle, is 90 degrees. Now we have another theorem. If we have 2 segments that are tangent to the circle, like this one, so this one is tangent to the circle, the other one is as well tangent to the circle, and they are crossing each other in the point M, because these are lines, the tangent, so they need to cross somewhere. So they're crossing each other in the point M. Then the segments are congruent. That means that the line LM is the same as the line NM. Is it clear, everything till now, for everyone? I guess so, because no one answering. Okay, so now we have one exercises. We need to find the length of the both lines. So ML, M, or MN. That will be, as we see that ML is equal to MN, that means the lines will be the same. So we just need to find one of them. How we will find? We need to solve this equation in order to find it. So let's do it. So we know that the length of this one, so this line, is the same as the other one, or we know that 2x plus 9 equals to 3x plus 6. So now we're solving equation in order to find x. We can subtract as you wish. We can subtract 2x from the both sides in order to have on one side just x and the other one just the numbers. So if I subtract 2x from the both sides, I'll just write it down like this. So I'm just subtracting 2x from the both sides. we will get on this side 2x minus 2x equals 0, so it's just 9. And on the other side, we will have 3x minus 2x, that is 1x, or just x, plus 6, the one that is left. Now, we want x to be alone on this side. So we want to subtract again. Here we have plus 6. We wanted to get it to 0, so I subtract 6 from the both sides again. So we'll have 9 minus 6 equals to x plus 6 minus 6. Or we have that 3 equals to x, or is the same if I write down x equals to 3. So now we find out how much is x. And we can find out how much is the length of mn or ml is the same, because we said that is the same one.
Excuse me,
So
Professor. Excuse me. We cannot see you. Your camera is off. Yeah. Thank you.
Yeah.
Thank you.
Okay, so now because it's the same one, we can just enter x in the first one or the second one, so it will be 2 times 3 here. If I put it in the first one, we have, instead of x, I put 3. We have 2 times 3 plus 9, and that will be 6 plus 9, or will equal to 15. That's the length of mn. So the length will equal to 15 centimeters, if we said that this one is centimeters. It's not written, but anyway. So mn will equal to 15 centimeters. The same will be the length of ml, because as we said, they're the same. Is this clear to everyone?
Yes.
Okay, great. So, sorry, 2 seconds. Okay, so now we have 4 arcs. What is an arc? That is a line segment. That is like this red line that we are having here. So minor arc is an arc whose points are on or in the interior of the center angle. So this is like the center angle that we are having here, A. And if it's inside it, that is minor arc. So because it's the smallest one. If we have the same angle, but the red line is the opposite one, this one, like in this case, then we have that the points are in the exterior of the center angle. So this one, that means this is the major arc. So this is the difference between minor and major arc. Now we have adjacent arcs. These are 2 arcs that are adjacent if they are in the same circle and intersect in the exactly 1 point. So that means that are one next to each other. So we have like 2 angles next to each other, have ones like the same radius here. So that's why the arcs are the same. We can do addition of them. If we are adding the first one plus the second one, we can add them together. And that will be like the sum of the 2 angles that are formed. So for example, if I have given one of these arcs, the length of one of them, and then I have the arc of the other one, I can find the total arc from R till T. This is the perpendicular bisector theorem. So if we have a circle and the radius is perpendicular to the chord, if you remember, chord was the line, it was line segment, not a line. This one, the blue one here, like the light blue in this picture, that it bisects the chord and its arc. So it bisects it. So it means that the sides, this side and the other side are the same as is given here. And as well, the arc is given, that is given, it bisects onto the 2 same arcs, because the radius is perpendicular to the chord. That means it's in the angle of 90 degrees. So let's do now for the area of sector. So sector is like the one that we have with the arc. Everything that is inside the circle is called a sector. So that is enclosed by two red radiuses, and they are intercepted arc. So this blue inside is the area of the sector. How we can find out how much is the area of the sector? It will be the area of the whole circle, as it says here, by the fraction of the circle covered by the sector. That means, so the area of this circle times the degree of the angle that we have here. So this is the formula, r square p is the formula of the area of circle. And then we have here is the angle, so fraction of the angle. M is the angle of the sector. So this small angle, it can be 30 degrees, 40, 50, 60. It doesn't matter how many degrees it. We divide it by 360 because the whole circle has 360 degrees. So this is how we can find the area of this sector. As well, like here we have the arc. So we can find the arc length is the distance along arc measured in linear units. So we need to find the circumference of whole circle times as again the fraction of the circle covered by the arc. So again, we need to find, we have the circumference of the circle, that is 2 pi times r. And then we have the angle here, that's fraction of the angle. For example, if the angle is 30 degrees, it will be 30 over 360 because 360 is the angle, like it's the whole circle degree, the degrees of the whole circle. So it's the fraction of it. Then we have, now we have one exercise, another one. So we need to find the area of the sector and the arc length given the radius and the angle. So we have the radius, that is 4 centimeters. We have M, the angle is 45 degrees. And we are going to use these formulas that I just show you guys. So the previous two formulas in order to find the both. So first, let's find the length of the arc. That was like the formula was 2 times r times pi. That was, I will just write pi like this. So 2 times r times pi, this was the circumstance of the circle. And then we multiplied by the fraction of the angle. So then we need to multiply. The angle is 45 degrees, as it says here. M is 45. Anyway, I will just write down like first the formula. Fraction of the angle divided by 360 degrees. Now we can insert inside what is given. So we have 2 times r. Instead of r, I will put 4 because r is 4 times pi. And then times, 45 degrees divided by 360. So now we need to calculate all of it. We have that 2 times 4 is 8, pi times 45 divided by 360 is 0.125. So in the end, we get that the length of the arc will be so 125 times 8, that's just 1 pi. So I can write it down, then the length of the arc is just pi equals to pi Do you know how much is pi? I guess everyone has studied this before. So pi is the constant that is 3.14. So I can write down that L equals 3.14 centimeters. Okay, so now we can find out, this is the length of the arc. Now we can find down the area of the sector by using again the formula that we mentioned before. So first we had the formula of area of the circle. Of the area of the circle was r squared. So r squared times pi. So times pi. And then again, I have like the fraction times the fraction of the angle that is given divided by 360. That is the 360 that are given degrees of the whole circle. So we'll have the area equals to r, in our case, is 4. So r squared will be 4 times 4 times pi. And then we have times the angle divided by 360. Or we will have that it will be 2 pi. Because we have 4 times 4 is 16 times 0.125. That will give me 2 times pi or 2 pi. Or I can multiply it and we will get the area. Instead of pi, I will put 3.14. And we will get that the area is 6.28 centimeters square. So centimeters square. Is this clear how we can find? This is like really easy example. Just we need to enter the given stuff into the formula. So I think it was clear to everyone.
Clear for me.
Okay, so let's do the next one. Okay, so now we have kind of the same exercises, but it's kind of more difficult. So it's kind of rotated a little bit. So we need to find the area of the sector. So the area of this one, if it's given the length of the arc, this is the length of the arc and the angle. So first, what we need to find out. Can someone help me? Tell me what we need to find out first. A little interaction that I know you are listening to me.
Yeah, I can hear you.
Okay, so what we need to find first, if we know the length of the arc and the angle, what we are missing in order to find the area. What is unknown that we don't know here? So in the other exercise, it was given the angle and one more thing that we needed to enter in order to find the formula that now we're missing. Someone has any idea what or no? No. Okay, then I can start. We are missing the radius because the radius is important that we need in everything. So that's why we have the length of the arc and as well the angle, so we can find the radius. When we will find the radius, we will have the radius and the angle and we can find the area, okay? So first, let's write down the formula again. So the formula for the length of the arc was 2 times r times pi times the fraction of the angle divided by 360. Now, I can put inside what is given for me. So it's given L, so I can put, instead of L, I will put 0.417 pi. Then on the other side, I have 2r. We don't know how much is r. Pi, I will leave just pi as it is. And then I had the fraction of the angle. So times the angle is given is 30 degrees divided by 360. So now the first part I will just, like here, we have on the both sides pi. So because we have it on the both sides, and we have just multiplication, I don't have anything with plus and minus. I can just eliminate pi on the both sides. So what will be left on this side will be 0.417 will equal to 2r times, we need to find how much is the fraction. So 30 divided by 360, and that's 0.083. Now, given that, again, I copy on this side, and on the other side, I need to multiply 2 by this number. So times 2, and then I will get so I multiply 2 times 0.083, and I get 0.167 times r. So now, in order to find r, what I need to do, we need to divide by this number on the both sides. So I need to divide by 0.167 on the both sides. So we will get that r will equal to 2.5. So now we will have that r equal to 2.5 centimeters. So now I can find out how much is the length of the area of the sector, sorry. We have given r, we have given the angle, so I can just put it inside. So now, how was the formula? Does someone remember the formula, or I just need to repeat it again? So again, the formula
I don't
was
remember the formula. Sorry.
the area of the circle, so r squared times pi. Times the segment again. So the segment was m divided by 360. Does someone has any question till now?
Not for now. Thank you.
Okay, great.
Thank you, guys.
So
It's
Remember,
okay, guys.
there's-
Thank you.
Yeah, there's no bad questions. So if something's not clear,
Yeah,
feel
everyone
free.
can ask if something, yeah, it's not clear.
It's okay. Yeah, what Professor Emilia was referring to before is whenever we look at the problem, we have to kind of step back and see, okay, what is the data that we have, and what is the data
Yeah,
that
what you
we are missing?
need to find.
Right. And so if the problem has 3 variables or 4 variables, we have to figure out which ones we have and which ones we don't, and then we can set up the formula to solve for that missing variable. So thank you, Professor
Yeah,
Emilia.
thank you, Ricardo.
My pleasure.
Okay, so now we have, instead of r, I put 2.5 that we find is on square, so I multiply by itself times pi. Then I had again the section that is 30 given here, divided by 360. So we have that the area will equal to So 0.5215 or will be 1.625. This will be centimeters squared. So I just multiply all the values given. I think that's clear. Here, I just multiply all of them, and I get this number. Then I multiply by pi, so I get how much will be the area of this sector. Is it clear, everything, this exercise to everyone? It's kind of the same with the previous one, just is a little bit harder because you need to solve equation instead of just adding the values inside. So
Yeah, it's clear for me.
it's clear. Sorry, I don't hear. It's kind of, you're not so loud. I need, is it clear to everyone?
Yeah, I can hear you.
Okay. So let's go to the next one. So now we have inscribed angle. Is an angle that is form of two chords of a circle with the common endpoint. So that means that this one is one chord. So FG is one chord and FE is another chord. So the chords have the same endpoint, that is F. Then the angle EFG is called inscribed angle. So we have two chords with the same endpoint, and the angle they form is called inscribed angle. So inscribed arc is the arc that this angle actually is forming here. So this is the arc that we're having. And now we have the inscribed angle theorem. That is that the measure of inscribed angle is half of the measure of is intercepted arc. So that means that this angle that is inside, that goes to the center of the circle, is twice as big as this inscribed angle. And it's the same length, 2x. This one will be, the arc will be the length of this angle as we saw till now. So this is one of the theorems, and this is usually like, this is one of the most used for exercises because they can be given like really tricky problems that are really easy to solve, but you need to think of the solution. So it's kind of logical exercises. So we have like the inscribed angle theorem. There are different ones. So by described angles subtended by the same arc are equal, sorry. So that means we have one arc of here, or here we have one chord, AB. That means that every angle that is here, I can like draw down like multiple angles. They all will all have this angle will all be the same. And the angle here that will be in the middle will be 2 times this x, 2 times this angle of each of these. Is it clear, this one?
Guys, it's clear. If you have any question, please let.
It's like this. That means that, like, for example, this one is 2x and this one will be x. And x will be this one too. It will be for the same one. That can be another one. Let me draw a little bit. So for example, here I can have like this another one. And that x will be the same. Then I will have here another one. And this will be the same x again. So they will be all the same ones. And now we have that inscribed angle is a semicircle is 90 degrees. So if we have diagonal, you know, the two radius from one diagonal, and the angle that is formed here is 90 degrees. That means it's a right angle. This is really important theorem, actually, that is 90 degrees. Usually they give it on the competitions because it's really hard, like to think of the solution. They will give you just one angle to find this one, and you really need to like really think that this one is right angle in order to solve with Pythagorean theorem. So this is like important theorem that you will have. And then we have that inscribed angle is half of the center that we mentioned before. So this one is another one. Okay, so now we have two examples again. So the first example, we need to find how much is this angle and this one here. How we can solve it? Does anyone?
Repeat, please. Repeat.
So Jose,
So,
Jose
yeah,
is
yeah, yeah,
asking if you can repeat. Thank you, Jose.
yeah, I will repeat. This one or the previous slide, sorry. Okay, so I don't know if you want to repeat me this one or this one, because this one I will just start it. I need to solve like the both problems, and let's see how to solve them. Like now we see like that this ones, like for the first one, for example, we have these both have the same arc. So this is the same arc that they're having. And this is the chords that are intersecting this one point. So now, as we saw before, and we mentioned that this angle is half of this central angle that is on the same arc. That's really important, that the arc is the same for the both of them. So knowing that, we can find out how much is x, and we can solve the equation. So what we can solve, that this angle here, we have that twice of this angle, the small one, will give me one of this big one, because we know that this one is twice the other one. Is this clear?
Hey guys,
Yes,
is
it's clear.
this is clear?
Guys, it's okay?
Yes, I guess.
Thank you. Thank
so.
you.
Okay,
Thank you.
Jose, thank you. Thank you, teacher.
Okay, so if this one is x, this will be 2x. Is this clear for everyone? I guess yes. So we need to find how much will be the angles. Does anyone have idea how to find out?
Mateo, this no?
This is easy because it's given that one is twice the other one. So which one is twice the other one? So this angle is twice of this angle. So if this angle is 2x, should be equal to the other one, that is x plus 18. So now we can find out how much is x. In order like to have just x on one side, we can minus here x on the both sides. And we will get that x will equal to 2x minus x. Sorry, I will write down like the whole equals to x minus x plus 18. Or just x will be 18. Is it clear?
Yes, it's clear.
Okay. So let's do the next one. Here we have the other one that is given that we have the second circle. Again, here we have we can use the previous theorem. We have that this arc is the same. So that means that this is one angle here. So the angle LMN, so this angle, and this angle LPN will lie on the same arc. Do we see this? Everyone, does it see it? I guess yes. So they lie on the same angle. So that means that the angle LMN, as the theorem said before, is equal to the other angle LPN. So that means, so we have that LMN angle is the same as the angle LPN. Why? Because they're on the same arc here. They have like the same arc, so we set every angle that is on the same arc are the same. So that say that we will find out that the angle LPN equals to 55 degrees because it's the same as the previous one. Okay. So this was
Okay, Professor.
So now we have 4 equations of a circle. So what is equation of a circle? Equation of a circle is a circle, is a given circle, and we need to find the equation. The equation, this is the formula for the equation. So x minus h squared plus k squared equals to r squared, right? Let's first explain what is everything. So r is the radius. H is the x component, and k is the y component of the center. So it's the point in the coordinate system with the h first coordinate and k second coordinate. So here we have one example. Here is given circle with the radius of 3 centimeters and the center with -2, as we says here. Just write them down. Like for example, here is -1. Here we have -2. So we see that on the x-axis is -2, and on the y-axis is just 1. So the center is -2 with 1. And we have the radius is 3 centimeters. So now we can just enter what is given into the formula. So we have -2 and 1. So we have x, because here is -2 and here in the formula is minus. Let me just write it down. Will be like x minus, we have -2, then we have plus. Now we are going on the second one, y minus 1, because it's 1, equals to radius squared, that is 3 squared. This is just to explain this, how we get this, the bigger one here. Or we will have this one, we will get from that the first formula, this one here that we are showing, because we have x minus times minus will give me +2 squared plus y minus 1 squared, and will equal to 3 times 3, that is 9. Is it clear, the formula? So this is the formula that you need to remember.
Yes, it's so
Okay.
clear.
So now we have one exercise with this one that we need to find out. I didn't mention one more thing. So one more thing, like here, if we have circle that is in the center, so it's not like moved like this. So that means that the center of the circle that is in the coordinate center, that means that x will equal to, so the center will have the x coordinate will be 0, the y coordinate will be 0 as well. So we write down the equation, and for example, the radius can be the same, 3 centimeters. Then we can write down like the equation. We'll have x minus 0 squared plus, I will square it afterwards, sorry. Y minus 0 again squared will equal to 3 squared. So because when the circle is in the center, it's easy. So will be x minus 0 is x squared plus y squared will equal to 3 squared or 9. So that's really more easy because we will have like the coordinates of the circle, of the center of the circle will be 0. So we will get the formula that x squared plus y squared will equal to r squared, or the radius squared. So this is a formula when the circle, like it's really important when the circle is like exactly in the coordinate start. So it's where they intersect x and y. So here is the center of the circle. Okay. So let me now go to the next exercise. So we have another exercise that is given a circle in the plane x, y, and that has a diameter with that points. One is 8, 10, and the other minus 2, 0. We need to find the equation of the circle. So now it's given the diameter of the circle. Let me draw. That means it's given like one point here. That can be, I'll put M, that has these coordinates. Sorry. So one point has coordinates 8, 10. And we have diameter. And the other point has coordinates minus 2 and 0. This can be written as well. Maybe it will be easier for you in the coordinate system, but anyway, we can find the solution without using the coordinate system because sometimes it's just in the middle, so you cannot really find the point. So first, what we need to do, this one is the distance, the length of this diameter. So why we need the length of the diameter first? Does someone know why we need the length of the diameter? What we are going to find with the length? What we need to find for the equation of the circle, what we are missing. So this is what we need to think. First, we need the center. First, we need to find the center of the circle. And what else? We need to find the radius. So the length of the radius. And what we know that the length of the diameter, that the diameter is twice radius is. So that means that the length of the radius will be half of the length of the diameter. So let's find the length of the diameter. This is the formula. So we can put like here in this given. This one can be x1. This can be y1. This can be x2. And this can be y2. And we just need to replace it inside, like put it inside the formula. So we will have that the length of the diameter will be x2, that is minus 2, minus x1, that is 8, that will be squared, plus the second one, we have y2 is 0, minus y1, that is 10. So let me just write down. So this is squared, and we have square root on top of it. So we will have that the diameter, the length, will equal to minus 2 minus 8. That is, the both are with the same sign. We copy the sign, we add them together, so will be minus 10 squared plus of the second one is again minus 10 squared. So have square root minus 10 squared plus minus 10 squared. Then we know that when the number is squared, even though it's with minus sign, the sign will be minus times minus, so will again be positive. So the first one, 10 squared, will give me 100, plus the second one is another 100. So this will be the square root of 200, the diameter, the length of the diameter. Or I can write it down. $200, like 2 times 100. How much is square root of 100? Does anyone know? You should know. The square root of 100? That is 10, because 10 times 10 will give me 100. So we will have the diameter will be 10 times square root of 2. So this will be the length of the diameter. So now in order to find the length of the radius, we need to divide this one by half, because the radius is the diameter divided by 2. Or just the radius will equal 10 square root of 2 divided by 2. I can divide 2 by 10 divided by 2, that will be 5. 5 over 1, or just 5. And I just copy square root of 2. So this is the length of the radius. So we find the radius. Now we need to find the center of the circle. So how we can find out how much is the center? So the center, the first point will be x2 minus x1 divided by 2. So minus 2 minus 8 divided by 2. And the second one will be how will be the second one? So will be 0, 2, So we'll find out that the center will equal to minus 10 divided by 2, that is minus 5, and the other one will be minus 10 divided by 2, again the same. So now knowing that, we can find out the equation of the circle. That was x minus 5 squared. So this is the first point of the center. So we have this one that is important, and we have the radius. Then we have plus the second one, that is y minus minus 5 equal to the radius squared. So we'll have that the equation will be x plus 5 squared plus y plus 5 squared equal to, then we square the radius, that will be 5 squared, that is 25, times square root of 2 squared, that will be just 2. So we'll have that equation of the circle will be this one in the end. Is it all clear or no?
Okay, guys, it's clear. Everything is clear. If you have any question, you can talk.
Do you have any question? Because I'm just finishing. This is like the last one, I think. So if someone has anything unclear, can tell me.
Do you hear, guys?
Is everything clear to everyone?
Hey, guys. Do you hear the teacher? Matthew, Joss. Samuel, Stephen, Camila.
Thank you, Professor, please.
Okay, I guess everyone has everything clear.
Yeah,
So this is was the last thing here. So if someone has anything to ask, you're welcome to ask from everything that I said today. If not, I'm finished. So I hope you enjoy the class.
Yes.
Any student have a question, teacher?
Okay.
Yes. You can finish the class, teacher.
Thank you so much,
Okay.
everyone.
So
Thank you for
thank you,
joining us.
everyone.
Appreciate it. Good to have you, Amelia. Have a great evening.
Thank you.
Ciao,
Thank
ciao.
you, you too.
Teacher, have a
Ciao.
good day, guys.
Thank you, students. Good to see you guys here. Any questions you have, we can refer back to the lessons in the online course. So some of the problems that were covered today, if you want to try them again, or you want to practice again, go to the geometry class, and you can retake some of the lessons if you wish, to go through some of the material that Professor Amelia went through today. So thank you guys for joining us, and have a great afternoon. The next class is it today, Lourdes or Roxana? I think we have another class at 3 p.m. today, Eastern time.
2 p.m., yes.
yeah,
Okay.
it's in Spanish.
Okay, that one will be Professor
only-
Hutchings.
yeah.
Professor Hutchings will be at 3 p.m. So I hope to see you guys again there. Take care. Thank you, guys. Thank you, Professor. Ciao, ciao.
Thank you, Professor.
Bye. It's a pleasure.
Bye-bye.
Take care.
Thank you. Bye.
Bye-bye.